Hi, and welcome back to another video. Today we're going to take a look at the Pythagorean Theorem. One of the most important pointers about the Pythagorean Theorem is the fact that you can use the formula c squared is equal to a squared plus b squared to find whether a triangle is indeed right angle. What I mean by that is, for example, if they give you a question like this and they say, like, is this a right triangle? Which means that it has a 90-degree angle. It has to abide by this rule. So let's say we are given this triangle with the following dimensions: 13, 84, and 85 as its hypotenuse. How do we figure whether this is a right triangle? Well, if this is indeed a right triangle, then c squared should be equal to a squared plus b squared. That means that if you raise the hypotenuse to the power of 2, it should be equal to the addition of the two other legs. So is this in fact true? Is the hypotenuse equal to those two parts? Let's check it out. So first step is to plug in the numbers. It's going to be 85 to the power of 2. Is it equal to 13 to the power of 2 plus 84 to the power of 2? So if you calculate that, 85 to the power of 2 would essentially be 7,225, while on the other side you would have 169 plus 7056 or 7,056. So as you can see, these two sides are equal to each other. If you add 169 to that, you would get 7,225, which means that both sides are indeed equal to each other. What this shows is that this triangle is indeed a right triangle because it follows the rule c squared is equal to a squared plus b squared. So it is indeed a right triangle. It's pretty simple, right? Now, what if it's not a right triangle? What are the other scenarios that might exist for the triangle? Let's go down and take a look at some other examples. Well, first of all, there are two scenarios. One would be where you have a triangle like this. Let's say this is A, C, B, and the smaller sides are A, and this is C, and this is B. In the scenario that essentially the square of the bigger side, or the hypotenuse, is bigger than the addition of the two smaller legs, then your triangle is actually obtuse. So you have an obtuse triangle. Triangle is obtuse. And if your triangle, essentially the addition of the two other legs, are bigger, for example, let's say the triangle looks a bit like this. That didn't came out so good. Let me just, something like this, where this is A, C, B, this is C, this is A, and this is B. If the addition of the two smaller legs are greater than the hypotenuse, then your triangle is actually acute. So the triangle is acute. Now, there are multiple ways a question can come in the exam regarding these types of, I guess you can say, theorems. One of the ways is they would give you a word problem like this. They would give you, for example, example 2, classify the triangle whose side lengths are essentially 6, 11, and 14 as, is it acute, is it obtuse, because there's 3 types, or is it right? Is it a right triangle? Okay, in order to do this, well, first of all, you have to understand that the longest side is obviously 14. This is C, and these two other ones are A and B. So first, you're going to plug them inside. C squared is equal to A squared plus B squared. So that would give you 14 to the power of 2 is equal to essentially 6 to the power of 2 plus 11 to the power of 2. Are these two sides equal? Well, we have the calculator. 14 to the power of 2 is obviously 196, and that's 121 plus 36, which is 157. So actually 196 is greater than 157. right? Now, since the c square, that means that the square root, the hypotenuse raised to the power 2 is greater than the addition of the two smaller legs. That means that your triangle is, if you take a look at our rules, when c square was greater than the addition of the two smaller legs, then our triangle was obtuse. So similarly in this case, the triangle is actually obtuse. Now that's pretty much it. Thank you for watching and good luck.